Now we are going to do certain numericals which are based on electromagnetic spectrum. So the first is this: calculate wave number and frequency of yellow radiations having wavelength 5800 Armstrong. So that means first what is given, you've been given with wavelength which is 5800 Armstrong. So if I convert in meter, it comes out to be 5800 into 10 raised to power minus 10 meter, right? So now what I need to find is, I need to find the wave number first. So wave number, we know that there is a relation between wave number and wavelength. Wave number is equal to 1 upon wavelength. Putting the values, that is 1 upon 5800 into 10 raised to power minus 10. So you need to solve this. I think you know how to solve it. First, like it is in minus, when it will come in numerator, it will become positive. And then you need to solve it like this. So when you solve it like this, you will get an answer equal to 1.72 into 10 raised to power 6. So this is the wave number for the given wavelength. Second, we need to find the frequency, right? We know that there is a relation, that is nu is equal to C upon lambda. We already discussed when we were doing the spectrum. So putting the values, we need to find nu. C is probably the speed of light, and we know that it is 3 into 10 raised to power 8. Lambda is 5800 into 10 raised to power minus 10. So just try to solve it, and when you will solve it, you will get an answer equal to 5.172 into 10 raised to power 14 per second. So how we did this numerical? We just took the relations between the wave number and wavelength, and the relation between the nu and the wavelength. So this is how you just need to manipulate the formulas, and just according to that what is being given and what is being asked in the question. Second question we have is, the wavelength of range of visible spectrum extends from violet 400 nanometer to 750 nanometer. That means again you've been provided with the wavelength range ranging from 400 nanometer to 750 nanometer. So if I express it in meter, it comes out to be 400 into 10 raised to power minus 9 meter, and this is 750 into 10 raised to power minus 9 meter. So this is the range. Now what is being asked in the question? You need to express the wavelength in terms of frequency. Again, you are familiar with the relation nu is equal to C over lambda. So we are going to find, but we'll use the wavelength and we are going to find the nu in this case. So nu for this wavelength will be nu is equal to C over lambda. Nu is C, we know, is 3 into 10 raised to power 8. Lambda we have given 400 into 10 raised to power minus 9, and here again the same relation, that is nu is equal to C over lambda. So C is again 3 into 10 raised to power 8, lambda is 750 into 10 raised to power minus 9. So when you will solve it, you will get a answer equal to 7.5 into 10 raised to power 14 hertz extending to 4.0 into 10 raised to power 14 hertz. So this is how we have expressed the wavelength range in terms of the frequency, because this is the frequency range now, right? So this is like this, you will get a question where you'll need to find the nu or the lambda, and accordingly the other thing will be given. And moreover, wavelength and lambda are how they are related, wavelength and wave number and the wavelength. It is wave number is equal to 1 over lambda, or you can say that lambda is equal to 1 over wave number. So these are the few questions based on electromagnetic theory and the spectra.